Hello friends, welcome back to Secret of Electronics. In this video, we will learn how to control a common anode RGB LED using assembly code and the AT89S52 microcontroller. This circuit shows how to interface a common anode RGB LED with the AT89S52 microcontroller using port 1 pins P1.0, P1.1 and P1.2. The AT89S52 is powered with a DC 5V supply connected to its VCC and GND pins, an 11 MHz crystal oscillator connected between XTL1 and XTL2 pins, along with two 220 picofarad capacitors to ground, provides the clock required for the microcontroller to operate. A reset circuit is built using a tactile push button, a 10 kΩ pull-up resistor, and a 0.1 microfarad capacitor. Pressing the reset push button pulls the reset pin high to restart the controller. The common anode of the RGB LED is connected to plus 5V, meaning each color LED, red, green and blue, turns on when its cathode is pulled low. Therefore, port 1 pins P1.0, P1.1 and P1.2 control the red, green and blue channels through 220 ohm current limiting resistors. Driving these pins low lights up the corresponding color, and by combining different low-high patterns, various colors can be produced from the RGB LED. Right at the top of the code, we have a description of our project. We are using an AT89S52 microcontroller with an 11 MHz crystal oscillator and controlling a common anode RGB LED connected to pins P1.0, P1.1 and P1.2. There's one important note here. Because this is a common anode LED, writing a 0 actually turns the LED on and a 1 turns it off, so the logic is inverted. Next, the ORG 4 times 0H tells the microcontroller what to execute when it resets. We immediately jump to the level start to begin our program cleanly. To keep our code simple and readable, we define 3-bit red on P1.0, green on P1.1, blue on P1.2. Now instead of writing P1.0, we can simply write red. This not only makes the program easier to understand but also more professional. We then create a small subroutine called all_off. Since 1 equal LED off, this routine sets all 3 pins high and ensures every LED is turned off. We will use this whenever we need a clean start. Next comes the fun part, the color routines. Each of these subroutines lights up a specific color by clearing or setting the individual LED pins. So_red turns on only the red LED. So_green, so_blue, same idea. So_yellow lights red plus green. So_sand is green plus blue. So_magenta is red plus blue. And so_white lights up all 3 LEDs together. Each color is neatly packed into its own tiny function. This is what makes the code modular and easy to expand. Now to make each color visible long enough, we use a delay routine called delay_long. This function uses 3 nested loops to create a delay of roughly 1 to 2 seconds when using an 11 MHz crystal oscillator. It is a simple software delay using the D, J and Z instructions, not extremely precise but perfect for LED effects. Inside start, we first write 0xFF to port 1. Since 1 equal off, this turns all RGB pins off right at the beginning. And here's the heart of the program, the main underscore loop. The microcontroller displays each color one by one: red, green, blue, yellow, cyan, magenta, white, and finally all LEDs off. After displaying each color, we wait for a full 2 seconds before moving to the next one. At the end, SJMP main underscore loop sends the program back to the top, creating a beautiful never-ending sequence of colors. This is how your RGB LED cycles through all the colors in a smooth, controlled pattern using nothing but pure assembly code. Now we will use an Arduino Nano as an ISP programmer to program the AT89S52 microcontroller. Connect the ISP pins of the AT89S52 to the corresponding ISP pins of the Arduino Nano. I have already uploaded the Arduino ISP code to my Arduino Nano board. If you want a complete tutorial on how to program the AT89S52 microcontroller, you can watch it on our YouTube channel. Now open the Kill Vision software and create a new project. I am naming this project RGB_LED. After giving the name, select the AT89S52 microcontroller under the microcontroller list and click OK. When it asks to add a startup file, click No. Next, right click on Target 1 and select Options for Target 1. Go to the Output tab and enable the Create Hexa file option. Then click OK. Under Target 1, you will find Source Group 1. Right click on it and select Add New Item to Group Source Group 1. Choose Assembly File from the file type list and give it a name. I am naming it RGB_LED. After naming it, click OK. Now paste the assembly code, which you can copy from the link provided in the description. After pasting the code, save the file. Once saved, click on Translate. If you see 0 errors and 0 warnings, it means the code has compiled successfully. Finally, click on the Build option. This will generate the hexa file and save it inside the Objects folder. To find it, open your project folder and look for the Objects directory. Inside it, you will see your hexa file. Now we will use AVRDUTE to upload the hexa file into the AT89S52 microcontroller. If you want a complete tutorial on how to upload a hexa file to the AT89S52 using AVRDUTE, you can watch it on our channel. First, connect the Arduino Nano to your PC or laptop using USB cable. After connecting, open Device Manager and check which COM port your Arduino Nano is using. Next, move the hexa file into the AVRDUTE folder. Then open Command Prompt or CMD inside the AVRDUTE folder. Run the first command and make sure to replace the COM port with your own. After that, run the second command and again remember to replace both the COM port and the hexa file name. Once you run the second command, the hexa file will begin uploading to the AT89S52 microcontroller. After the upload is complete, disconnect the Arduino Nano from your PC or laptop and remove the Arduino Nano connections from the AT89S52 microcontroller. Now connect the RGB LED to the AT89S52 according to our main circuit diagram. Now connect the circuit to a 5V DC power source. After connecting it, you will see the RGB LED glowing in different colors that we defined in the code. If you liked this video, then do not forget to subscribe our YouTube channel to watch more interesting upcoming tutorials. And if you have any project ideas or topics for which you want a tutorial video, you can tell me in the comment section. I will try to make it.